Last year I attended Open Source in San Francisco. It was an absolutely crazy time. I met heaps of you guys in person, saw amazing crazy projects from people all around the world, and met other fellow creators in the space. And as part of that event, we all got given these. Now these are attendee badges, and these are actually made from PCB material, usually used to make circuit boards. Now I was just playing around with some combat robot parts on my desk with the badge nearby, and it clicked. This is the perfect size to use as a base plate for an Antweight combat robot. So let's turn the open source badge into a destructive combat robot and fight it to the death. Let's get started. How's it going, guys? Angus here from Maker's Muse, and yes, I am coming back to open source this year. It's only a few weeks away. It's June 14th to 16th in San Francisco again, and I can't wait to meet you guys. I'm really thankful that the open source team are actually funding my flights this year, so I don't have to raise heaps of money to get there. But if you want to help with other expenses, I am bringing back the Ultimate Model Pack for 1 week only, and then it's gone. I mean it forever. I'm actually clearing a lot of old models off the Maker's Muse store. You'll never be able to get them again. So that is the last chance you've got. If you missed it last year, that you can get it again this year for 1 week only. Then it's gone, and I really appreciate the support. It's not required, but it's always appreciated. So let's go back to this badge. What is it, and why could this be suitable for a combat robot? Well, PCB material is actually a type of fiberglass composite. And I've shown this sort of material on the channel before, but I've used it for a very different purpose. Some of you may remember years ago, I showed that you can use Garolite or G10, which is a fiberglass composite sheet, as a really effective 3D printing surface. This material is really versatile. It's very stiff, very lightweight for the stiffness and the strength, and also it's non-conductive and resists high temperatures. It's actually very difficult to even set fire to, which makes it fantastic for PCBs, but also very good for combat robot applications. And this badge just happens to be the perfect size for an Antweight combat robot. Here in Australia, our Antweights weigh 150 grams. That's it. Literally the palm of your hand. Some of you may have seen this robot, which is Pancake. This is the latest version that's been refined down, and it's got a TPU frame, so it's all flexible and resilient. This huge undercutting bar. This whole thing weighs 150 grams. That's it, and it's hugely destructive. And I really like the undercutter concept of Pancake, so can I take that idea and use this badge as the base plate? Well, let's find out. And the first step is to translate this real-world object into a reference in the 3D modeling software that we can then use to start our model. And my favorite way to do that accurately is just to get a flatbed scanner, put the object in, and then put a ruler next to it and scan the image. Now, putting the ruler next to the object is critical because when you bring this image into your software, it will be flat, but it won't be to scale. So what you need to do, for example, in Fusion, is you choose 2 points of that ruler and assign a value, which is the exact measurement of what it should be, and it will scale the image perfectly, so where you have an almost identical one-to-one reference of what you're actually trying to recreate in the digital space. And that's just one of many tips I actually share in my ebook, The Ultimate Guide to 3D Printing, and you can find that linked in the description below, and it's also got a special price, again, for 1 week only. From here, I like to grab all the parts I've got, have them on the table with me with a pair of calipers, and measure those parts and put them in to the model using a sketch. So often I'll use the first sketch with construction lines to just sort of mock out where I want the parts. For example, where the battery bay will be, where the electronics will go, where the motor's gonna go. I like to make sure I draw a circle for the blade's actual like circumference. So like as it's rotating, will it hit where the wheels are gonna go? Stuff like that. And I tend to do this using a lot of constraints to make sure that as I change things, the model can update accordingly, and I can make sure I have it as efficient as possible. Which takes us to the badge. Now, this material is quite lightweight, but still, it's quite a substantial amount of our 150 gram budget. So what I decided to do is design in these pockets that take away material while leaving these edges to make sure the part was still quite stiff and resilient. And for the weapon, I'm going for this undercutter style design like Pancake has, but using a small motor, and to support that motor, I'm actually putting a bearing on the output shaft, which should, in theory, absorb a lot of the impacts as it hits things at speed. So the thing is, I can't 3D print any of that. I can't do that by hand. That is a job for CNC. But it just so happens I know another robot builder who also has his own YouTube channel who has a fantastic Tormach CNC, and he's known as James from Broken Link Robotics. You may have seen some of his creations on the channel before, like when he beat my robot into submission and my robot caught fire.
Oh, there you go. Hey!
Yeah, that guy. So here's James showing you how he machined this badge into a base plate for my robot.
My name's James, and I've got the job of turning this CAD model into this part using this CNC machine.
If you're unfamiliar, one can think of a CNC mill as a very heavy, powerful, reverse 3D printer. It's got 3 axes of movement driven by some chunky stepper motors, and a spinning tool spindle that can hit just over 10,000 RPM. While being more suited for heavier metal jobs, today it's handling finer operations using an ML designed for cutting PCBs. Normally an entire part will be cut out of some larger stock, but as we're modifying an existing part, there are things to consider. Firstly, we can't hold the badge down with clamps or the vise, as we need access to the whole face and sides. Thankfully, the final part needs 5 bolt holes, which can be leveraged here. Firstly, a 3D printed PLA block will snugly hold the badge to drill these holes. Then a second block will fixture the part for the rest of the operations. Unlike a 3D printer, we need to confidently know where the existing stock is in space. For this, we're using a very accurate CMM probe.
It's worth mentioning that the way the probe detects things, it actually deflects when it hits stuff. It's sprung loaded and it's got 3 load cells in there that can detect the slightest touch, and that's how you know when it's bounced off of a part.
Moving the machine around, the probe is touched against 2 far apart sides of the vise to align it with the horizontal machine axis.
So this is definitely below the actual accuracy of the probe, but we are allegedly within 0.001 millimeters from this point to this point in this axis, which I think is pretty good.
The Operation 1 printed block is next clamped in the vise, and the probe used again to find the left-hand center of the part. This is the reference point that the G-code instructions are based around, and any and all deviation in this measured location will be translated directly into our machined part.
So what we've gone and done is we touched the probe off on this side of the part and on this side of the part, and taken the difference between those. So that difference is 99.46 millimeters, and half of that is roughly 49.72. So if we tell the machine that's where the middle of our part is, we'll be able to start machining. And this is meant to be 100 millimeters when it was printed, but you can see how there's actually quite a difference between. Look at that. It actually turned out really good. Alright, on to the next step.
The holes appeared to be in the right location, so the part is mounted to Operation Block 2 for the final machining. This block is dialed into the machine much like the previous one, but reprobed due to the difference in dimensions.
You can see the tool, this is as far out as it goes, it's just between that gap between the vice draw and the part, and that's where it will come down before it starts that contour, which you'll see when it cuts. If the tool touches the vise, it will definitely just explode, so it's very critical, we can say, to get that gap correct, not fly too close to the sun, but still give it the room that needs to move. You know what? That turned out pretty damn good. Got no idea why these burred up. Well, these pockets look absolutely immaculate. But anyway, as long as the customer never sees this footage, I guess.
Well, thanks for that, James. It looks spectacular. It's really, really cool how much weight it actually saves machining those pockets out of this badge. It's quite substantial, and again, every gram counts when you're working at such small weight classes. The way I like to prototype is to get a design pretty much done, but not spend too much time fussing over small details and then sending it to the printer, because I know the first version most likely will have problems, and of course they did. Just small things where the wires weren't routed properly, or the motors didn't quite fit correctly. Then I went back to the drawing board a few times, and then when I was happy with my design, I wanted to print it with a cool looking name for the robot. Now, Fusion isn't very good for doing complex typography and logos and designs and that sort of thing, but it can import an SVG and use that as geometry to then create details on your model. So to create that detail, I used a program called Affinity Designer. This is part of the Affinity suite from Serif, and if you've used Adobe software, then I would highly recommend checking out these programs, because you buy them once and you're done, and I am so happy with them. So I use Designer, which is like Illustrator, and I use Publisher, which is like InDesign, and they work fantastic. So for this robot, because open source is a play on the word, I decided to call him Ketchup, and this is what I came up with. So once I'm happy with this design, I brought it back into Fusion as an SVG, punched it out of the top of the model, and from here, I really wanted the text to stand out, because if you just print it in one color, well, you won't really see it, will you? So I brought it into Bamboo Studio, and I used the painting tool to then print this part multicolor on the A1 Mini. And this was the result. Now, granted, it's pretty stringy. We've just had 2 solid weeks of torrential rain and literal floods, so even PLA is stringy at the moment, but I think this looks really cool. The text stands out fantastically, and most importantly, all the parts fit, or at least seem to. So now we get to the most fun stage of making Antweight combat robots. The wiring. Yes, as you can imagine, it's as fiddly as it looks. Now to get these machines moving, you need a few key components. You need a battery to provide power, you need a speed controller, and you need a receiver, or in this case, I'm actually using an all-in-one unit called a Malenki Nano. So this actually has the receiver built into it, and 3 drive channels, and 2 outputs for your weapon, because in this case, I'm using a brushless outrunner. I have a brushless ESC to run that motor. Now, it's only a few parts, but all of these have to be joined together with wires, and routing these wires is an art in itself. I use a fine-tip soldering iron to solder them in place, and I always make sure I plan very carefully how long each wire is, because wires can add up in weight and they take up space. So in tiny little robots like this, you need to measure them precisely, so there's a little bit of wiggle room. They're not going to be too tight where they might break. I tried to film as much of this as I could, but as you can imagine, soldering these tiny little things is such a fine art that I just put on some chill music and went to town, and I ended up with this, which is possibly the cleanest wiring job I've done to date on an Antweight robot, but it's still fairly serviceable if I need to replace things like the drive motors or weapon motor. And that's the thing, because they will be destroyed. It's a combat robot. They break each other. But either way, I'm very happy with the result. To hold the base plate in, I used threaded inserts, and they just pushed into place. And a little trick that I learned from a few other builders, if you put the threaded inserts from the other side down instead of from the side facing the part you're fastening to, they would have to pull out through the material, and it makes them a lot stronger instead of just pulling out of the material like they normally would. Now, this is a great tip and awesome if you can pull it off, but in my case, the bore for the insert was so deep that the insert tool was actually too large and melting plastic around it as I forced the insert down into place. So that's something I didn't really consider. It's much stronger to do it this way, but then you have to have access to putting the insert in from that direction. So yeah, even though I've built countless machines like this, I'm still learning all the time. For the blade, I used this disc that I originally had on Pancake, and James had cut this out for me previously out of an old saw blade. So it's like a high carbon steel. I have no idea what kind it is, but it's actually held up pretty well, and it seems to be fairly resilient. But most importantly, it's very thin, so it cuts right through other robots. Even robots made out of TPU, people have found out how durable and resilient TPU actually is in terms of taking blows and keeping the machines going, but thin blades cut right through it and can be a real game changer in terms of hitting components that are inside that TPU frame. So because most people build robots out of TPU these days, I tend to run the thin blades because it cuts right through it. And then after lots of finessing, here we have it. This is Ketchup. This is my Antweight combat robot made on the open source badge. I just love the aesthetics of it. The badge looks so cool with the typography, the colors and everything. and now it's got a blade sticking out the front of it. I just think it looks so cool. And so, like, what's really surprising to me is how well this robot drives. Having the weight distributed properly so the wheels are actually between the battery and the weapon motor means it drives much better than machines I've built in the past, where all the weight's at the front and the wheels are at the back. It's a lot easier to control, and it's actually really zippy as well. The N20 gear motors I've used are really fast. I don't know how well they'll last, but they have a lot of speed to them, which is all you really need for a spinner, because I'm not trying to push people around. So I've built this really cool robot, but what's the point in just building a machine and not using it? So I invited James over with his own Antweight combat robot that he's built to have a few grudge matches. And this is how it went.
Domination. Oh, that is probably stuck.
The brushless motor I'm using for the weapon system in this robot is 4,000 kV. What that means is it spins 4,000 times per volt, and it's running a 7.4 volt battery, a 2-cell lithium battery. That is insane speeds. Now it's not going to be reaching, max theoretical speed, but as you can see, at this scale, physics kind of breaks. This machine, when it's at full speed, is more stable on its side than it is on its wheels, because the gyroscopic precession of that blade at full speed just locks it in place. And I just love this slow motion capture of the machine coming around and just showing like an advertisement for open source as it drifts across the screen and then goes out of sight, hits a wall, and just flies off across the arena. And this arena is designed to handle the forces involved, which is good because at the end of our fights, this happened.
More stable on its side now. Hey!
Yeah, the blade literally flew off at full speed and ricocheted around the arena. Now this combat robot arena is purpose built for fighting Antweight combat robots. I built it using my own money with a lot of help from other builders to help support this hobby in Sydney, Australia, because these Antweights are a great way to get into combat robotics. They're small, they're accessible, they're affordable, and the skills you learn designing these is transferable to so many other industries, bigger robots, different hobbies. I highly recommend checking out the sport if you're at all interested. And after our grudge matches, as you'd probably imagine, catch-up is pretty worse for wear, but much less than I expected. The same can be said for James's robots, however. For his lifter, it did suffer some catastrophic damage with the weapon blade reaching in and getting some drive components. The armor pods on the side also got destroyed, but they were intentionally made from very thin-walled PLA because it looks really cool when it blows up on slow-mo. And this robot, I think with TPU or even some titanium side armor, would be really durable and difficult to beat, even with a powerful spinner, because in our arena, the pit opens at the last minute, and so many machines get pushed down that pit, no matter how destructive they are. And James's other robot with the lifter and vertical spinner took this massive hit from the weapon blade on Ketchup, and you see it just hooked into the side of the vertical spinner and just bent it. It was tons of fun having these grudge matches, and I really appreciate James coming around. But yeah, I might owe him a few parts after that. And this weapon motor, it's not super happy anymore. The shaft is actually slightly bent, despite having the bearing, but it does still spin, which is amazing considering the forces involved and how many violent impacts it experienced. The blade as well, despite being quite thin steel, a little bit bent, a little bit chewed up, but again, perfectly usable. And I did lose one drive motor because these N20s, I buy them cheap on AliExpress and they are a real mixed bag. So thank you so much guys for watching. I hope you found this video interesting. I always love the fact that creativity can come from the most random places. Like, I just had this badge on my table with robot parts for another build, and I was just like, oh, I could just put the motor there and the disc there. And I was like, wait a minute, this is the right sort of material. And from there, a whole robot design was born. So, like, ideas can come from the most random, unexpected places. Keep your eyes out, keep creative, and I can't wait to see you guys at Open Source if you're going. There's links in the description below to find out more. It's going to be a long flight, so yeah, if I have a huge energy drink in my hand, don't be too surprised. I'll catch you again very shortly. Bye, guys.